On question number 4, we're trying to solve the system of equations by using the substitution method. Now the first step of the substitution method is we need to isolate one of our 4 variables. And I'm going to choose to isolate the top y because the other 3 have numbers in front of them. And if we were to try and isolate for one of those other 3, then we would potentially be creating fractions, and that would be more work. So the y on the top only has a negative sign in front of it, although we will have to deal with that as well. So let's subtract 4x from both sides, and we get negative y is equal to 9 minus 4x. And then the negative sign is like a negative 1. So if you divide everything by negative 1, we get y is equal to negative 9 plus 4x. So I've isolated for the blue y, and now I'm going to take that expression and plug it in to the other equation for the green y. So I want to copy the green equation, but instead of putting y, I'm going to leave a big open parentheses because that's where I'm going to plug in the blue equation. So you'll notice that this equation only has x's. It does not have x's and y's, it just has x's. So this is something that we can solve. So if I distribute, that is 3x plus 45 minus 20x is equal to 11. And then if I combine like terms, negative 17x plus 45 is equal to 11. And then subtract 45 from both sides. We get negative 17x is equal to negative 34. And then if you divide both sides by negative 17, then x is equal to 2. So we're almost there. We have our x value. Now we just need to find our y value. So if we plug it into this equation here that we found in our step 1, then we should be able to find what y is equal to. So y is equal to negative 9 plus 4 times 2. So y is equal to negative 9 plus 8, or y is equal to negative 1. So I have my x value, I have my y value, so my final answer is 2 comma negative 1.